Good day everyone, I am Sir Aldrin Murillo, one of the instructors from the Mathematics core of Search, and we will introduce you all to the first discussion of Mathematics core, and it is about introduction to limits. We'll have four parts, which is finding a limit, the limit theorems, limits at infinity, and infinite limits. So, to formally and mathematically define a limit, it is the value that a function approaches when its input approaches a certain value. The notation of a limit of f of x can be shown in the slide below. It can be written in the form below. The notation of it can be read as the limit of f of x as x approaches to a, with a as the given value and f of x as the given function. The limit of the said function will be beside the equal sign, and that limit notation will be on the other side. As a form of warm-up, evaluate the value of a given of the expressions given the value of x. For x squared minus 7, where x is equal to 3, x plus 2 all over x minus 2, where x is equal to 0, 3x plus 27 over x, where x is equal to negative 3, 2 over x minus negative 2, where x equals 2, and 8x plus the square root of 64x squared plus 16x, where x is equal to 8. So to find the limit, one of the ways to find its limit is to directly substitute the value where the input approaches. That is one of the most common and easiest ways to find the limit. Kung titignan mo na lang sa definition, we can formally infer that a limit of the function can just be the value of a certain function with a given x value. So for an example, evaluate the limit of x squared minus 9 where x is equal to 9. We have just to substitute 9 across all the x's in the said function. So by doing that, we can find that the limit of x squared minus 9 where x is equal to 9 is equal to 72. Now, let's try these further exercises. The limit of x plus 4 all over x minus 1 where x is equal to 3. The limit of square root 3 minus the limit of square root of 3 minus x where x is equal to negative 1, and the limit of x raised to the 4th plus 3x raised to the 3rd plus 5x squared plus 7x plus 9 where x is equal to 2. Let us move forward to the limit theorems. For the first part, it is the constant theorem, which says that if c is a constant and a is any real number, then the limit of c as x approaches to a is equal to c. This is known as the constant theorem. Another theorem is the sum theorem, which states that if f of x and g of x are defined functions on a, then the limit of f of x plus g of x as x approaches to a is also equal to the limit of f of x as x approaches to a plus the limit of g of x as x approaches to a. Another is the product theorem, which states that if f of x and g of x are defined functions on a. Another is the product theorem, which states that if f of x and g of x are defined functions on a, then the limit of f of x times g of x as x approaches to a is equal to the limit of f of x as x approaches to a multiplied by the limit of g of x as x approaches to a. Simply put, the limit of the the limit of the product of two functions equals to the product of the limits of the two functions. We can infer that the sum theorem and product theorem are all applications of the distributive property of addition and multiplication. So, we can visualize it. Another is the quotient theorem, which states that if f of x and g of x are defined functions on a, and the limit of g of x as x equals to a is not equal to 0, then the limit of f of x divided by g of x as x approaches to a is equal to the limit of f of x as x approaches to a, all divided by the limit of g of x as x approaches to a. Also, another application of the distributive property of numbers. Now let's have some examples of the given theorems. Evaluate the limit of 5x squared minus 7x plus 2 as x approaches to negative 2. We can apply the thumb theorem in this problem. So now, the limit notation is distributed among all the terms of the function. Now we'll have the limit of 5x squared as x approaches to negative 2 minus the limit of 7x as x approaches to negative 2 plus the limit of 2 as x approaches to negative 2. Now, we can see that in the last term, the concept of constant theorem is applied since 2 is a constant. So now we just use simple algebra to further solve the given problem. So now we'll arrive to the final answer, 36. So the limit of 5x squared minus 7x plus 2 as x approaches to negative 2 is equal to 36. Another example, the limit of x squared times the cosine of x minus 3 as x approaches to 3. Now we can directly imply the product theorem in the said problem. So we now have the limit of x squared as x approaches to 3 multiplied by the limit of the cosine of x minus 3 as x approaches to 3. And now we'll apply simple algebra to further solve the problem. And the final answer will be 9. The limit of x squared multiplied by the cosine of x minus 3 as x approaches to 3 is equal to 9. Finally, as the last example, we have the limit of 3x squared minus 9x plus 6 multiplied by 5x plus 1 all over 4x minus 1 as x approaches to 3. Looking at this example, we can apply the product theorem and the quotient theorem consequently. So after we applied, we will now have the limit of 3x squared minus 9 plus 6 as x approaches to 3 multiplied by the limit of 5x plus 1 as x approaches to 3 all over the limit of 4x minus 1 as x approaches to 3. In that, we can also apply the sum theorem. So now we will have 3 multiplied by the limit of x squared as x approaches to 3 minus 9 multiplied to the limit of x as x approaches to 3 plus the limit of 6 as x approaches to 3 all multiplied by the limit by 5 times the limit of x as x approaches to 3 plus the limit of 1 as x approaches to 3 all over 4 times the limit of x as x approaches to 3 minus the limit of 1 as x approaches to 3. Further algebra will follow, and you will apply the substitution of 3 across all the x's. So now we'll have 96 over 11 as the limit. We can conclude that the limit of the said function is 96 over 11. So as an exercise, let's try to evaluate the following limits. The limit of x squared minus 8x minus 128 as x approaches to 4. The limit of x squared minus 10x minus 10 all over the logarithm of x as x approaches to 10. The limit of the cube root of x over 1 minus the cube root of x as x approaches to 8 over 27. And the limit of 20 minus x cubed multiplied by the logarithm of 1 minus 3x as x approaches to negative 3. A while ago, I said that the concept of finding the value of x or the unknown variable in a given expression can also be related or associated with the concept of limits because they have the similar concepts and processes. However, I said similar because they are not actually the same. Now, we have the infinity symbol, which we did not yet encounter as our previous levels when we discussed like substituting a given equation. Now we have the limits at infinity. Given n is greater than 0, it is known that the limit of 1 over x raised to the nth power as x approaches to infinity is equal to 0. This applies when the given limit is infinity and the given function is a rational equation. with x in the denominator. Now let's solve some examples. Evaluate the limit of x minus 7 all over 2x plus 1 as x approaches to infinity. Let us first divide the numerator and the denominator by the highest exponent of x. In this case, x. As we do it, we will have the limit of 1 as x approaches to infinity minus the limit of 7 over x as x approaches to infinity all over the limit of 2 as x approaches to infinity plus the limit of 1 over x as x approaches to infinity. Now, on the second terms of each term, the numerator and the denominator, we can now apply the limits at infinity. The limit of 7 over x as x approaches to infinity is 0, and the limit of 1 over x as x approaches to infinity is 0. Simplifying, we now have 1 minus 0 all over 2 plus 0, which will give us 1 half, and that is the limit of the given function. Another example, we will have the limit of 3x squared minus 3x plus 1 all over 5x squared plus 11x minus 4 as x approaches to infinity. Again, let's divide the numerator and the denominator by the highest exponent of x, which in this case is x squared. As we do this, we do further divisions of the variables, and as we further simplify, we now have the limit of 3 as x approaches to infinity minus the limit of 3 over x as x approaches to infinity plus the limit of 1 minus x squared as x approaches to infinity all over the limit of 5 as x approaches to infinity plus the limit of x plus the limit of 11 over x as x approaches to infinity minus the limit of 4 as x approaches to infinity as x approaches to infinity. Using again the concept of limits at infinity, all the terms with an x in the denominator will have a limit of 0. Simplifying all will give us 3 minus 0 plus 0 all over 5 plus 0 minus 0, which is equal to 3 over 5, or 3/5. So now let's have these exercises. Let's find the limit of 7x cubed minus 3x minus 1 all over 9x cubed plus 7x squared plus 5 as x approaches to infinity, and the limit of 7x squared minus 8x minus 9 all over 3 cubed minus 2x squared plus 3x plus 4 as x approaches to infinity. Now let's move on to the final part of this lesson, which is infinite limits. Let's keep in mind that the limit of 1 over x as x approaches to 0 from the right is equal to infinity, and the limit of 1 over x as x approaches to 0 from the left is equal to negative infinity. Since we can visualize it as we go to the right of the Cartesian plane, we can see that the 0 to the right approaches to the infinity, and we can see that the 0 to the left approaches to negative infinity when we try to visualize it. So now, let's move on to the examples regarding infinite limits. Evaluate the limit of 3 over 3 minus 3 as x approaches to 3 from the right. Just the same, let's plug in 3 to the right to the equation to the x. So now we'll have 3 all over 3 to 3 plus minus 3. 3 from the right minus 3. So we all know that as a certain value is from the right, it is equal to positive infinity. So now we'll have 3 all over 0 from the right, which is equal to 3 multiplied by infinity, which is now equal to infinity. Another example, let's evaluate the limit of 1 over 5 minus x as x approaches to 5 from the right. Do the same, plug in the 5 from the right, substitute. We'll have 1 all over 5 minus 5 from the right. Do arithmetic, then we'll have 1 all over 0 from the left. Since we know that 1 over 0 from the left is equal to negative infinity, then the limit of the said function is equal to negative infinity. As exercises, find the limit of negative 6 all over 4x minus 28 as x approaches to 7 from the left, and find the limit of 7x plus 1 all over 8x plus 24 as x approaches to negative 3 from the right. And that wraps up our first audiovisual presentation for the mathematics core of the STEM Engine Review and Tutorial Center for this semester. If you have further questions, please don't hesitate to contact us through private messages. We can communicate. Thank you and have a great productive day ahead.